Okay, I'm going to do a quick explanation of quiz 3.2C and of the answers. And so you can check your answers and make sure this goal is understandable to you. All right, so first off, they ask us to use this scatter plot that we have right here and to use a calculator to find the least squares regression line. Most of the time you will not have to use your calculator to find this, but this is just so you can get the least squares regression line. Make sure that when you write this out, you have y hat, which is the predicted value. Okay, so you need that y hat right there because that tells you the predicted value. You also have your y-intercept, which is your right there. And then you have your slope, which is located there. Now you want to include your x variable or your y variable. You want to define these either by putting them in the equation, or you can define them here. Y is the price in dollars and x is the screen area. The next thing they ask you to do, so that would be the key components that you need for any least squares regression line. All right, define it. All right, need find variables and need y hat for predicted value. And what else do you need? All right, you need an equation. Okay, proper equation. All right, those are the things you need. It says, what do you need to do the least squares? What does it mean for least squares and the least squares regression line? Well, you're talking about the least squares of the sum of the residuals. I didn't put that in there. The sum of the residuals. Okay, and that's what you're looking for. That's why it's called least squares. It's the sum of the residuals. For C, it says this manufacturer also produces a television screen which is with a size of 943 square inches. Okay, would this be reasonable for that? We're talking about extrapolation here, so you need to say no. All right, so you need to answer the question. To answer your question, and then what you need, all right, for this one is a proper response. Okay, all right, proper reason. And the proper reason in this case, all right, is that no, because 943 is outside the range of the data set, okay? Outside the range of the data set. And you can see the data set goes from, all right, 154 all the way down to 683 for screen area. And this right here is 943, which is outside of that screen area data set values for our explanatory variable. Okay, and so that would be what you're looking for there. Okay, so that will probably be a question that you will see on a test as well. Now, the next thing is calculate the residual. Okay, so what do you need to calculate a residual? Well, you need your work. And the work is you need to take the actual minus predicted and get your answer. Okay, and that's what you have here. So you need that one for you to get the residual. Next thing is then it needs to say, what does this number suggest? So now you need to interpret. Now there's different ways of interpreting the residual. But the key thing is identifying what is happening here. So generally what I like to do is say, okay, what is larger? So the predicted cost at 437. All right, so this is what we see. So the predicted cost at 437, screen size is 66.855 inches squared larger, because the predicted is larger, all right, larger than the actual cost for that same size, okay, at that size. You could also say that the actual cost at 437 inches screen size is 66.855 inches squared less than the predicted cost for that size. You could do it the other way around as well. All right, so those are the key things that you need when you're going through here. Okay, going on for the next page, all right, number 2, if you turn it, what you have is another plot. All right, you have to know how to read this. Just so you are aware, I'm just going to put that is the standard deviation of residuals. Okay, this is our R squared value, which will give you as a percent. Right here, these are the main indicators you need. This one, the constant, is the y-intercept. And this right here, when they have the minutes and that value right there, that is your slope. So when they write this, when it says write the equation of the least squares regression line and define our variables, you need to say, okay, x is minutes. All right, how do you know that? Because that's our explanatory variable. It's on the x-axis. And then y is the number of floors. All right, well, it's not really there. All right, so y, those are the residuals. All right, and then we have our equation that we're going to write out. Okay, make sure you have your y hat. So once again, what do you need when you're doing this, when you're writing the equation? You need to define variables. Okay, and you need y hat, or your predicted hat. Identify that. And then finally, you need an equation. All right. The next one says, is the line appropriate model for the data? Now, if you want to figure out the appropriate model, you need to have a residual plot. This is a residual plot, and you need to compare that. And that's what you're going to use. All right. So what you're looking for, is there a pattern? It's going up, then down, it's going negative, then positive, negative, then positive, negative, positive. So that I would not say that is a distinct pattern. So there appears to be no distinct pattern with the residual plot. So it is a linear model is appropriate. That's what we're looking for. So what do you need to say? All right. So need to answer the question. And the question is the line appropriate model for this? And then you need to, in your response, use residual plot. All right, analysis. I'll just put that. And if you see a pattern, you say no. If you don't see a pattern, then a linear model would be appropriate. And then finally, interpret the S value that you see up there. S is the standard deviation of the residuals. So what are some key things you need for this in your response? Well, standard deviation you need, all right, to say, need to know that the actual, all right, y variable, or y variable, okay, so what is the y variable here? The actual number of floors. You need to include typically varies. Typically varies. Or you can use average distance. All right, so whenever you're talking about standard deviation, okay, in this case, we're talking about standard deviation of the residuals. You need to have the actual y variable. That's a variable. Geez, we can't even write it. Variable. Okay, variable. Need to include typical varies. All right, that you can see right here. There. And then what is happening is that typically varies from this need, typically varies from predicted. Y, whatever that is, y values from least squares regression line. Okay, because that's where you get it from. And that is where you have that. And that's what it typically varies by. That's what the standard deviation of the residual is. Okay, standard deviation is the average distance from the mean. Well, we don't have a mean in a bivariate data. We actually have a linear regression line. So we always compare it to. All right, so I hope this helps you out. We talked about residuals and how to do that. We also talked about the y-intercept and the slope and all of the cool stuff. Okay, and in the other problems, I'm going through some other values which are in some other videos. All right, well, good luck and God bless.